Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening.
Good evening. All right. Just some time back, I realized that, the last one for question number 7, the working was different, but I had attached the working was not for the figure which I had attached. Probably you did not make out that, some of you who have completed the assignment. The answer which was there pertains to this figure, but the figure which I had attached in the assignment I had sent to you had a different figure. I'm sorry about that. Okay, let's understand the answers now. Yeah. So find the number of rounds that a wheel of diameter 7 by 11 meters will make in going 4 kilometers. So simply remember this equation or formula, children. Okay. The circumference of the wheel, okay, circumference of the wheel. So now if you just think more about it, you will realize that circumference of the wheel is the distance covered by the wheel in one rotation or revolution, whatever you call it, or in one round. Circumference of the wheel is nothing but distance. See, circumference is a length. Circumference is not area. Circumference is the length of the boundary of the circle. So in this case, the circular wheel, it's the length of the circular wheel, the length of the boundary of the circular wheel. So the circumference of the wheel is nothing but the distance covered by the wheel in one round. Circumference of the wheel is nothing but the distance covered by the wheel in going one complete round, or one rotation, one revolution, whatever. So this is nothing but the distance covered in one round. Distance covered. There's nothing but distance covered in one round. Like that, you should understand that. You should understand this like that, distance covered in one round is the circumference of the wheel. Think about it. Circumference is the distance covered in one round. So distance covered in one round into number of rounds. Will be the total distance you have covered, right? Will be the total distance you have covered. Whatever is the distance, supposing in one round you're able to go, say, just for example, 2 kilometers. In one round, not on the wheel, some round, okay, you're going around a park or something. One round, you go 2 kilometers. So if you make 5 such rounds, so distance covered in one round is 2 kilometers. If you're doing 5 rounds, 2 into 5, totally 10 kilometers. So the distance covered in one round into the number of rounds will be the total distance covered. So here, the distance covered by the wheel in one distance covered in one round into the number of rounds is equal to the total distance covered. This is the equation, children. If you remember this equation, any question based on this wheel, distance, number of rounds, you can answer is equal to the total distance covered. Just remember this equation. You should understand this one. Now this distance is nothing but the distance covered in one round is nothing but the circumference of the wheel. That's all. So what is the formula? Circumference of the wheel into number of rounds is equal to the total distance, total distance. And what is the circumference? It's a distance covered in one round, into number of rounds is the total distance. Now, what's the circumference? 2 pi r. What is circumference of the wheel? 2 pi r. Into number of rounds you should find. Okay, and what's the total distance? 4 kilometers. What is important is whatever, see, 2 pi r is length. 4 kilometers is also length. If you find 2 pi r in centimeter and you substitute 4 kilometers here, your working will be incorrect. Whatever unit you have 2 pi r in, the same unit you must have the distance here. That is very important. Either have both in kilometers or both in meters, both in centimeters. Circumference is nothing but 2 pi r into number of rounds is what we have to find. Is equal to total distance, which is 4 kilometers. So total distance, 4 kilometers. Number of rounds we have to find. Circumference is easy. We can find 2 pi r. 2 pi r and r also we know. Diameter is given, so I can substitute r and find. So everything is given to you. You just have to work and find the answer. But what is very important is 2 pi r, if it is in centimeter, this also should 4 kilometers should also be converted to centimeters. If you have 2 pi r in meters, see, how will you know that? Whatever is radius, see here, diameter is in meter. Diameter is in meter. So 2 pi r answer will be in meter. So that means 4 kilometers also should be converted to 4,000 meters. See, how do you know the unit for circumference? Whatever is the unit for the radius. Whatever is the unit for the radius. So here the diameter is 7 by 11 meters. So radius is in meters. So 2 pi r, your answer is in meters. So that means 4 kilometers should be converted to meters, which is 4,000 meters. Or if this is in centimeter, you should convert 4 kilometers to centimeters. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, that's all it is. That is all it is. See here. So I found it separately. This is the formula. See, circumference of the wheel into number of rounds. Circumference of the wheel into number of rounds. I've been telling you repeatedly, this is the distance covered in one round. Distance covered in one round. So the distance covered in one round into number of rounds is equal to the total distance. Very practical equation this is. You cannot forget this. Number of rounds will be, what will be number of rounds? You know this, no? You can substitute here itself. You don't have to write this also. You can just substitute here itself and get the answer. I've just written number of rounds is equal to total distance by circumference of the wheel. Total distance by circumference of the wheel. So total distance I've found here. What's the total distance? 4,000 meters. It's given here. So 4,000 meters. And what's the circumference? 2 pi r. Diameter is 7 by 11. So radius will be 7 by 11 divided by 2. If the diameter is 10, the radius is 10 by 2. So 10 into 1 by 2. Just 1 minute, children, I'm coming. Yeah, children. So when the diameter is, 10 meters or whatever, so radius will be 10 divided by 2 or 10 into 1 by 2, 5. Similarly here, what is the diameter? 7 by 11 divided by 2. Divide by 2 to get the radius. So 7 by 11 into 1 by 2, which is 7 by 22. 7 by 22. So see here, diameter is given, find the radius, and hence find the circumference. So on working the circumference, you find 2 meters. Circumference is equal to 2 meters. What is the distance? What's the total distance? 4,000 meters. Sorry, yeah, 4,000 meters. See, you should have it in the same unit, meter, meter. If this is in centimeter, this also should be in centimeter. Because in one formula, you should use the same units. When you're using a formula, all the values must be substituted in the same unit. Any unit, but same unit. In one formula, all the values must be substituted in the same unit. You can even convert 2 meters to centimeter. Then this 4,000 meters also should be converted to centimeter. You'll get the same answer. That's all. Then just substitute in this formula and find the number of rounds. See, you don't even have to do this. I'll tell you. Because this one question, which is very easy, sometimes children find it very difficult. So I'm just telling you, write this formula. You can take down this answer. Circumference of the wheel into number of rounds is equal to total distance. You can now write it along with me, is equal to the total distance covered. Total distance covered. Circumference is 2 pi r. Into number of rounds is what we have to find. Number of rounds is equal to the total distance covered. So diameter is in meter. So 2 pi r is going to be in meter. So 4 kilometers, you write it as 4,000 meters. Total distance covered is 4,000 meters. Now 2 into 22 by 7 into r, 7 by 22 into number of rounds, okay, is equal to 4,000. Like this also you can do, I'm saying. So 22, 22, 7, 7 gets cancelled. So 2 into number of rounds is equal to 4,000. So number of rounds is equal to 4,000 divided by 2, which is 2,000. Even do it like this. All right. Yeah, shall we go to the next one, children?
Yes, ma'am.
Yeah. All right. Okay, so in this figure, OPQR is a rhombus. OPQR is a rhombus. 3 of whose vertices lie on a circle with center O. Yeah. So the vertices P, Q, and R of the rhombus lie on the circle with center O. So that means one vertex of the rhombus lies at the center or is the center of the circle. One vertex of the rhombus is nothing but the center of the circle. The remaining 3 vertices lie on the circle. So in the given figure, OPQR is a rhombus, 3 of whose vertices lie on a circle. P, Q, and R, they lie on the circle, and the other vertex is nothing but the center O. If the area of the rhombus is 32 root 3, the area of the rhombus is 32 root 3 centimeters square, find the diameter of the circle. So we'll understand what the rhombus is actually made of. Now we know that every quadrilateral is made up of 2 triangles. Every quadrilateral is made up of 2 triangles. Okay, here you can see 4, but along one diagonal, I'm saying. Along one diagonal, it's made up of 2 triangles. Along any one diagonal, okay? So if you take this rhombus, along any one diagonal, supposing you connect this diagonal, you can see 2 triangles. Or this rhombus, if you take this diagonal, you can see 2 triangles. You can see 2 triangles. Okay. So now, look at this figure. Now we are going to prove that OPQ is equilateral. We are also going to prove that ORQ is equilateral. OPQ is equilateral. ORQ is also equilateral. See the triangles. OPQ and ORQ. They are the two triangles on either side of the diagonal. They are the two triangles on either side of the diagonal OQ. There are two triangles on either side of the diagonal OQ. We have one OPQ and the other ORQ. We are going to show that these two triangles are equilateral. How? All right. So to show that it's equilateral, you'll have to show that all the sides are equal. Okay, which are the sides of triangle OPQ? Tell me the sides of triangle OPQ. Which are the three sides of the triangle OPQ? Why? You won't help me?
OP, OQ, and QP.
And PO.
PO? OP, PQ.
Sorry, ma'am, PQ.
Yeah. Okay. Now, which is the radius in this? Is OP the radius?
OQ and OP radius.
Yeah, OP and OQ are the radius. OP and OQ are the radius. So is OP equal to, now which is in these three? Okay, OP is the radius. OQ is also the radius. What about PQ? What about PQ? It's a side of the rhombus, correct? It's a side of the rhombus.
Yes, ma'am.
PQ is the side of the rhombus. PQ is the side of the rhombus. But OP and OQ, they're the radii of the circle. So already two sides are equal then. In the triangle OPQ, already two sides are equal. OP and OQ are equal. You must show that all the three are equal. That is, it's equal to PQ also. So how do you do that? Now see here. Take up this radius. Now tell me the radius which is also the side of the rhombus. Tell me the radius. No, see, we are talking about these three. In these three, tell me the radius which is also the side of the rhombus.
OP.
OP. OP. OP is a side. OP is a side of the rhombus. OP is a side of the rhombus. It's also the radius. So is OP equal to PQ? Is OP equal to PQ? Yes, because all the sides of the rhombus are equal. In a rhombus, all the sides are equal. In a parallelogram, only opposite sides are equal. But in a rhombus, all the sides are equal. So OP is equal to PQ because the sides of a rhombus are equal. Yes or no?
Yes, ma'am.
But OP is equal to OQ because radius. But OP is equal to OQ because radius. So when you compare these two results, we have OP is equal to PQ is equal to OQ. All the three sides are equal. So the triangle is equilateral. So 1 minute. Let me do it more, still slowly. See here, I'm taking the two triangles OPQ and ORQ. Is this understood?
Yes,
I'm
ma'am.
going to show that these two triangles are equilateral. Now I'm just writing out the sides of this triangle. OP, PQ, OQ. The sides of this triangle, OR, OQ, RQ. Then I'm going to choose that side in this triangle, which is also the, okay, I'm going to choose one side in this triangle, which is both the radius and the side of the rhombus. OP is the radius as well as the side of the rhombus. PQ is only the side of the rhombus. OQ is only the radius. Yes or no? What is PQ? Side of the rhombus. What is OQ? Radius of the circle. What is OP? It is the side of the rhombus as well as the radius. I'm taking that one. I'm taking OP. I'm writing OP 2 times. And I'm going to say that OP is equal to PQ. That is, OP is equal to the remaining two sides. OP is equal to PQ and OP is also equal to OQ. Do you understand what I'm writing?
Yes, ma'am.
Now, why OP is equal to PQ? OP is equal to PQ because sides of the rhombus are equal. And OP is equal to OQ because radii. Now tell me in the same way, tell me here, what is OR?
Radius as well as radius.
Radius as well as the side of the rhombus. What about OQ?
Radius.
What about RQ?
Side of rhombus.
Side of the rhombus. Take up that line segment, which is both the radius and the side of the rhombus. Which is that? Which is the line segment? OR. No. Answer my question. Which is that line segment which is both the radius and the side of the rhombus?
OR.
OR. So write OR 2 times. Now OR is equal to OQ. The remaining two sides. OR is equal to OQ. OR is equal to RQ also. OR is equal to OQ. OR is equal to OQ. OR is equal to RQ. Why is OR equal to OQ? What's the reason?
Radius.
Radius. Why is OR equal to RQ?
Side of rhombus.
All the sides of the rhombus are equal. Okay. Now from these two results, OR is equal to OQ, OR is equal to RQ. That means all the three sides are equal. That means OR, OQ, RQ, all the three sides are equal. That means ORQ is equilateral and here OPQ is equilateral. So we have proved that the rhombus is made up of two equilateral triangles with respect to the diagonal OQ. With respect to the diagonal OQ. On either sides, okay, actually, next class now I'll just correct this slide. This diagonal need not be connected. By mistake, I've connected this diagonal. This one need not be connected. The figure will be given only like this to you. You can erase it in your book. This diagram, you know, take out this diagonal. This will not be given. By mistake, I've connected it. Only this diagonal will be connected or nothing will be connected. So you have to connect this one. I said just take out this diagonal. This will not be connected. Okay, so now we have proved that the rhombus OPQR is made up of two equilateral triangles with respect to the diagonal OQ. So we are now good to go. Now we know that the area of the rhombus is equal to 32 root 3. It's given that the area of the rhombus is 32 root 3. But the rhombus is made up of two equilateral triangles. Area of one equilateral triangle is root 3 by 4 into side square. So two triangles like this. So 2 into root 3 by 4 a square. Yes or no? See, this is not the formula to find the area of a rhombus always. This is not the formula to find the area of a rhombus always. In this particular case, the rhombus is made up of two equilateral triangles with respect to the diagonal OQ. So this formula is very specific to this sum. This is not the formula to find the area of a rhombus always. So here, since the whole figure is made up of two equilateral triangles, one equilateral triangle is root 3 by 4 into side square. So 2. So 2 into. Correct? Yes or no?
Yes, ma'am.
Okay, root 3
Yes,
gets
ma'am.
cancelled on both the sides. Okay, root 3 gets cancelled on both the sides. And this is 2 1s are 2 2s are. Okay, so you have side square. Side square means any side of the rhombus you can take. Side square means any side of the rhombus. So substitute any side of the rhombus, but you have to find the diameter, no? So I have taken OP, or you can take OQ also. See, side square is any side of the equilateral triangle. You can take this side, or this side, or this side, or this side, or this side, any side. But you take up that side, which is also the radius. So maybe I've put OP. Yeah, I've taken OP. You can even write OR. You can also write OR. Okay. So we have side square. That is, say OR square. OR square by 2 is equal to 32. So OR square is equal to 64, cross multiply. OR is equal to 8, square root of 64, which is 8. OR is the radius, which is 8. So that means the diameter is 60. Understand, children? That is what I've worked here also. All right. Please acknowledge.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Maybe you can include the step. You can just write area of rhombus OPQR is nothing but area of equilateral triangle OPQ plus area of equilateral triangle OPQ and ORQ is equal to 32 root 3. So because it is the sum of two equilateral triangles, it is 2 into root 3 by 4 side square. So you can just include that. Understood, children?
Yes, ma'am.
How many of you have submitted your work?
Ma'am, I have submitted the first 5 sums. I still have to do 6 and 7. I'll submit it within today, ma'am.
Okay, see, Deepika, you've raised your hand, but Deepika, you've not drawn any figure, Deepika. Yes or no? Reply in the chat, Deepika.
Ma'am? Ma'am?
Yeah, yes, Ananya.
Should we send pictures, ma'am?
Yeah,
I finished it, ma'am. I forgot that we have to send pictures. Should I send it now?
yeah, please do it. Not now, after the class.
Oh, okay, ma'am.
But why, Deepika? So yeah, you did not draw, but why did you not draw? Okay, children, see, without the figure, how will you revise? I don't know. See, I don't know what you people are doing, but whatever we do here in the class is more than enough for, for your exam preparation. I'm setting the boundary, for your syllabus. You don't have to learn anything beyond what I teach you in the class here. You don't, just the tuition notebook is more than sufficient for you to prepare for the exam. See, these questions are not an NCERT. So it's all from different books, question banks and different books. So that's how my class is always. So this is more than sufficient for you. See, and every sum, is not explained like, so I don't do like, okay, OP is equal to OQ, then like this, so it is equilateral. Then this one, so this is equal. It's not like that. I tell you how to write also. How will you know that you'll have to write this? So that also is explained. So all these ideas, see, understanding the concepts delivered in the class, very, very efficient, effectively, plus practicing the same sums. This is more than sufficient. So anything new, anything different given in the paper, with all this knowledge you have very clearly, you can crack that sum, which you have not seen earlier. See, ideas matter. Your knowledge must be a collection of ideas. Your knowledge in mathematics should be a collection of different ideas. So anything new in the exam, you can definitely, work that with the help of all these ideas. So if you're just, attending the classes and working or practicing from some other books, it's not going to help you. In school, you're learning from NCERT. Here in the tuition, we learn something. But for the exam, you believe something else. You don't believe your school teacher. You don't believe me. You believe the book by some other author, or you believe the internet, or you believe something what somebody has told you. Like this, you cannot get good marks. I can say this very confidently. You must always practice what you have understood. Your school teacher has made you understand something. Practice that. And remember that. Here in the class, you're made to understand different questions here, different from what you learn in school. So in school, your teacher helps you with NCERT. Here we do something else. This is more than sufficient. So what you understand in the class, this should be put to practice. So like this NCERT and all these extra sums which we do in the class here combined is more than sufficient for the exam. This knowledge is more than enough for the exam. But you should have practiced the same thing. You must believe your school teacher. You must believe me. You must trust your school teacher. You must trust me. Practice only what we teach you. Don't do anything beyond this. Working out question papers, all that will not, you do all that later, not now. Now you should only sit practicing or working out should be only from the school classwork notebook or from the tuition notebook. Some of us feel I've already learned this in tuition. Why should I work the same thing again? You will not remember. We have worked it in tuition, but you don't remember how to do it. Now you go back to, linear equations or some other chapter which we finished long back. Each and every sum which you have understood in the class, you will not be able to work. You need to revise that. So please revise only from the tuition notebook. By doing this, I've seen many children coming out, with flying colors. Otherwise, I would have changed my strategy, right? I won't be preaching the same thing in the class. Many children who hate mathematics, hate numbers, have learned to love numbers with all their effort, I don't do any magic. So it's all with the help of their efforts. They help themselves. My work is just to teach you everything once. What else I do? Nothing. I just teach you once. And then you practice it several times to remember. So all credit to the students. Whether you do well or don't do well, everything goes to you. I don't add any feather to my cap. You don't do well, it is your fault. You do very well, that's all credit to you. Because I just explain everything only once. You are the one who practices it many times to remember and do your exam well. So I take no credit. But you should trust me and the school teacher. That is very important. Do not do anything beyond this. Practice the same thing repeatedly. You will do well. That's assured. You will do well. Do not refer. Don't refer R.D. Sharma. Don't refer any other book for that matter. Don't refer. Practice the same thing. See, I'm telling this itself so many times. Practice the same thing. I told you, it's a collection of ideas. So now working this sum, you've got some idea. So you should, visit this idea many times and remember this very clearly. You must visit this sum many times and remember the idea you get from this sum clearly. So like this, you will get a collection of ideas and all these ideas you should remember. It should be very clear in your mind. Then with all these ideas, any new sum in the exam, you will definitely crack it. Yeah. So I think I included something here. Yeah, so that's what it is. I think I finished explaining this, right? We are done with this one, right, children?
Yes, ma'am.
Yeah. So like this,
Yes,
we find the, I was telling you, see, this is not the formula to find the area for rhombus. In this situation, because the rhombus is made up of two equilateral triangles, we use this one. Okay. Yeah, this again, just the formula, children. See here, you're given the area of the sector. What's the formula? Theta by 316 to pi r square is equal to area of sector. We know this formula. Just write the formula. Theta by 316 to pi r square will give us the area of the sector. Then substitute. You're given some value, substitute and find theta. Theta is 72 degrees. Substitute the values given and work, you will find theta. Okay. ABCDEF is a regular hexagon. It's a regular hexagon. Regular hexagon meaning hexagon is a six-sided polygon. Hexagon is a six-sided polygon. Regular hexagon meaning all the six sides are equal and all the six interior angles are also equal. An equilateral triangle is a regular polygon. An equilateral triangle is a regular polygon because in an equilateral triangle, all the sides are equal and all the angles are also equal to 60 degrees. All three angles are equal. An equilateral triangle is a regular polygon because all the three sides are equal and all the three interior angles are also equal. A square is a regular polygon, is a regular quadrilateral because all the angles are equal and all the sides are equal. A rectangle is not a regular polygon. A rectangle is not a regular polygon. It's not a regular quadrilateral. It is a quadrilateral. It's not a regular quadrilateral. Or it's not a regular polygon because all angles are equal, but only opposite sides are equal. All the sides are not equal. So this one is not a regular quadrilateral or a regular polygon. A square is a regular polygon. A regular quadrilateral also. A triangle is also a regular polygon. Now this one is a regular hexagon, meaning all the six sides of the hexagon are equal. All the six sides are equal. All the six sides are equal in length and all the six interior angles, this angle, all the six interior angles are also equal. The measures of all the six interior angles are also equal. Okay. Now go down to 8th standard and recall the formula to find the sum of all the interior angles of a polygon. Okay. So because for triangle, we know the sum of for a triangle, we know that the sum of all the angles is 180 degrees. For in a quadrilateral, 360 degrees. And then in a pentagon, everywhere. Okay. So the formula to find the sum of all the interior angles of any polygon, it need not be regular. See, when you take a triangle, whether it is isosceles, equilateral or scalene, whatever triangle it is, the sum of the three angles is 180. Quadrilateral, whether it is a parallelogram, rhombus, rectangle, square, kite, what trapezium, isosceles trapezium, whatever it is a quadrilateral. So the sum of the four angles is 360 degrees. Three sides 180, four sides 360. Five sides something, six sides something, seven sides something. Whether it is regular or not regular, that's a different thing. Now the formula is 2n minus 4 into 90. 2n minus 4 into 90. Just a second, I have a bad throat. I'll just come back. Yeah, children. Yeah. So this is the formula to find the sum of all the interior angles of any polygon. This is the formula to find the sum of all the interior angles of any polygon. Now try. Now what is n here? N is the number of sides the polygon has. N is the number of sides the polygon has. Now a triangle has 3 sides, no? So 2 into 3, 6. 6 minus 4, 2. 2 into 90, 180. Number of sides in a triangle, 3. So n is 3. 3 2s are 6. 6 minus 4, 2. 2 into 90, 180. Quadrilateral has 4 sides. 2 into 4, 8. 8 minus 4, 4. 4 into 90, 360. A quadrilateral has, a pentagon has 5 sides. 2 into 5, 10. 10 minus 4, 6. 6 into 90, 540. So this is how you find the sum of all the interior angles of any polygon. Now this polygon has 6 sides. This polygon has 6 sides. So what is the sum of all the 6 interior angles? There are 6 interior angles. 1, 2, 3, 4, 5, 6. What is the sum of all the 6 angles? The 6 interior angles of this polygon. So 2 into 6, 12. 12 minus 4, 8. 8 into 90, 720 degrees. So the sum of all the angles of this polygon is 720 degrees. It's not 180. 180 is only for triangle. 360 is for quadrilateral. For pentagon, it's different. Hexagon, it is 720. You can also do this, children. See, another way is like this. Just take any vertex. Just take any vertex and divide the polygon into triangles. Take any vertex and divide the polygon into triangles. So see here, I'm connecting like this. This is one triangle. You can divide this whole polygon into 4 triangles here. Triangle 1, triangle 2, triangle 3, triangle 4. All these 4 triangles put together makes the whole hexagon. Yes or no?
Yes, ma'am.
Okay, so what is the sum here? 180, 180, 180, 180. So 720. But you work and show the meaning, use the formula 2n minus 4 into 90. Just telling you, you can also do this. Now, when you take a quadrilateral, when you join the diagonal, there's one triangle here, one triangle here. So 180, 180, 360 degrees. See, it's not like this. Okay, now don't say I can join both the diagonals. I'm getting 4 triangles. 4 triangles, so it's 180, 180. No. See, you should see here. Now, in this triangle, we have this angle, and this angle. In the other triangle, you have this angle, and this angle. Like this, we have taken all the 4 angles. Yes or no? If you join the diagonals like this, you will be finding the sum of all these angles. All these angles. Yes or no, children? You understand the difference?
Yes, ma'am.
See, this is, yeah, okay. So it's like this. So you can see here 4 triangles. So 180 into 4, 720. That's what you get using the formula also. That's all. So first, that's what you should first find. The sum of all the angles of a hexagon is 720 degrees. Now, the question is find the sum of the areas of the sectors with radius r. Sorry, with r as radius and centers being the vertices of the hexagon. Okay. So which are the sectors here? This is one sector. The center of the sector is this vertex A. This shaded region is a sector. This is a sector. The center of the sector is B. This is another sector. Center is F. Sector, center E. Sector, center D. Sector, center C. What is the radius? Radius is R. Radius is R. It's given. Radius of the circle is R. R. Everywhere it is R. Everywhere it is R. So the question is very simple. The question is to find How many sectors are there? 6 sectors. You should find the total of the areas of all the 6 sectors. That's all the question is. Not find the area of one sector. Find the area of all the 6 sectors. Find the total area of all the 6 sectors. That is the question. So the area of the sector with center A is whatever is the central angle. Angle A by 316 to pi r square. Pi r square, here r is r only. So pi r square. R is r only here. If the value of r is given, you can take. But what is r here? Meaning what is the radius here? R. So it's r itself. The area of the second sector is the central angle B by 360 into pi r square. Angle C by 360 into pi r square. Then for this sector, this is the central angle. This is the angle. Angle D. This is the sector angle or the central angle. Angle D by 360 into pi r square. And for this sector, this is the angle. This is the central angle or the sector angle is this one. Angle E. Sorry, plus angle E by 360 into pi r square. And for this sector, this is the center of the circle. And this is the sector angle, angle F. So the sum of the areas of the sectors, is equal to, this is what you see here. So pi r square by 360 is common. Pi r square by 360 is common. Everywhere you have pi r square by 360. So in the bracket, you will have angle A plus angle B plus angle C plus angle D plus angle E plus angle F. And what is the sum of all these 6 angles? It's not 180. It's not 360. The sum of all these 6 angles is 720. That's why we had to find it earlier. That's why we found this. The sum of all these angles is equal to 720. So in the next step, 720. Now simplify. 361s are 362s are. So it's nothing but 2 pi r square. Pi, the value is 22 by 7. So 2 into 22 by 7 into r square, which is 44 by 7 r square square units. Isn't it easy, children?
Yes, ma'am.
Yeah. So if it is a pentagon, if it's a pentagon, you know, it's a pentagon and you have to find the, sum of the areas of all the sectors like this. If it's a pentagon, then you'll have only 5 angles. A, B, C, D, E. You'll have only 5 angles. And the sum of the 5 angles you must find. 2n, 2 into 5, 10, minus 4 into 90, 6 into 90, 540 degrees. So angle A plus angle B plus angle C plus angle D plus angle E will be equal to 540. So see what I've written. Sum of the interior angles of a polygon. Any polygon, regular, irregular, whatever it is, the sum of all the angles, interior angles is 2n minus 4 into 90. And what is n? The number of sides. So here it is the hexagon. Here it is hexagon. 6 sides. So 2 into 6 minus 4 into 90. 720. Now, the sum of the areas of all the 6 sectors. The sum of the areas of all the 6 sectors is equal to, this is the area of one sector with angle A as a central angle. This is the area of the other sector with angle B as a central angle. See, every sector has a center, right? This is a center and this is the central angle. There's nothing but angle A. The central angle is nothing but angle B. See the sector, this is sector, right? Theta is this angle, theta by 360. This is theta. This is theta. And what is theta here? Angle A. What is theta here? Angle B. What is theta here? Angle C. Whatever is angle C is theta. Yeah, common. This one is 720. Simplify and use the value of pi and give the answer. Yeah. Arc A. You can see here, arc A is a part of the arc A is a part of the circle with center O. See here, arc A, this one, this is arc A, is a part of the circle with center O. So that means, see, this is the sector. This is the sector. O is the center. And this is the sector. So the radius of the sector is 10 centimeters. This is sector. This arc A is a part of the circle with center O. Why part of the circle? Because yeah, you can complete and get the circle, right? Sector is a part of the circle. See here, you could see that. You could see that here. See here, the sector is a part of the circle. Is a part of the circle. See, this sector is a part of the circle. All right. So this arc is a part of the circle with center O. With center O. Okay. And arc B is a part of the circle with center M. Center M. So for this arc, this is the center. That is with M as center. When you draw a circle, you know, with some radius, this arc is a part of that circle. See, with M as center and the radius is 5. You can see here 5 centimeters. The radius is 5 centimeters. You can see here. Radius is 5 centimeters. How? Because this is the arc, right? This is the arc. You can see here. This is a point of the circumference. So from the center to the circumference is the radius. This is the radius. So with A as center, with M as center and 5 centimeters as radius, when you draw this, when you draw a circle, you will get this one. You will get this arc. So this arc is a part of the circle with center M and radius 5. This arc is a part of the circle with center O and radius 10. That is what is given. This arc is a part of the circle because it's a big circle. See, with center O and radius 10 centimeters, children, please understand, with center O and radius 10 centimeter, when you draw a circle, this arc is a part of that circle. That full circle you cannot see here. You can see only an arc. With O as center and radius 10 centimeters, when you draw the complete circle, this arc is a part of that big circle. But you don't see the circle here. This arc is a part of that circle. That is what is given. So for this arc, any calculation regarding this arc, you must take the radius as 10 centimeters. And any calculation regarding this arc, you must take the radius as 5 centimeters. See here, 5 centimeters. Because 10 is the diameter. 10 is the diameter. Because arc B is a part of the circle with center M. Center M. And is given M is the midpoint of PQ. Center M and M is the midpoint of PQ. PQ is the diameter then. So that means this is a semicircle. Clearly this is a semicircle. Okay. Find the area enclosed by the two arcs. So you should find the area of this region between the two arcs. You must find the area enclosed between the two arcs. Enclosed meaning between the two arcs. Find the area contained by the two arcs. Area contained by the two arcs. This area you should find. So first, what is the idea? How do you find this area? This area is nothing but the area of the semicircle. The area of the semicircle minus the area of the segment. Minus the area of the segment. The area of the semicircle. This is a semicircle. This is a semicircle. The area of the semicircle. When you're finding the area of the semicircle, the radius is 5. The radius is 5. The area of the semicircle minus the area of the segment. If you take away the area of the segment, you will find the area of this region. Yes or no?
Yes, ma'am.
Yeah. Now, how do you find the area of the sector? Theta by 316 to pi r square. The sector. How do you find the area of the sector? Theta by 316 to pi r square. This is theta because this is the center of the sector. This is theta. Now this is an equilateral triangle. You can see this is 10 centimeters. This is 10 centimeters. This is also 10 centimeters. See here, this is 10. This is also 10. And this one you can see 5 plus 5, 10. So clearly OPQ is an equilateral triangle. So the sector angle is 60 degrees. The sector angle is 60 degrees because it's equilateral. So 60 degrees by 360 into pi r square. R is 10. Pi r, because you're finding the area of this sector. You're finding the area of this sector. So R is 10. So find the area of the sector. And from the area of the sector, take away the area of the triangle. Which is the triangle? Equilateral triangle. Root 3 by 4 into side square. This is the triangle. Take away the area of this triangle. You will get the area of this segment. You will get the area of this segment. I repeat, this is the sector. This is the sector which is made up of the triangle and the segment. This is a triangle, this is a segment. 1 and 2 together is a sector. Region 1, triangle. Region 2, segment. The triangle and the segment put together is a sector. Let's find the area of the sector. The sector angle is 60 degrees because OPQ is equilateral. So 60 degrees by 360. Sector angle 60 by 360 into pi r square. R is 10 centimeters. Will give you the area of the sector minus the area of the triangle. Root 3 by 4 into side square will give you the area of the segment. Will give you the area of the segment. Now find the area of the semicircle. Now find the area of the semicircle. This one. You have found this area now. You have found this area. Now find the area of the semicircle. What's the radius of the semicircle? 5 centimeters. This is the radius, 5 centimeters. Not 10. 10 is the diameter. See here. End to end is the diameter. This is the semicircle. So how do you find the area of a semicircle? Half of pi r square. Half of pi r square. See here. Semicircle. Area of a circle is pi r square. Semicircle is half into pi r square. Quadrant is 1 by 4 into pi r square. Because what's a quadrant? It's quarter of a circle. A quarter circle is a quadrant. A quarter circle is a quadrant. So this is 1/4 of a circle. So 1 by 4 into pi r square is the area. So area of the semicircle is half of pi r square, where r is 5. So find the area of the semicircle. And from that, take away the area of the segment. You will get the area of this region. See, if you're not understood, if you have not understood, tell me. You have not understood. Raise your hand, children. Lower your hands, and those who have understood, raise your hand. You don't have to please me. Yeah, the others must ask me questions and get your doubts clarified. Hitesh and Deepika. Deepika and Hitesh, what is your question? What's your doubt? Hitesh, you are completely non-responsive. Deepika, what's your question? No doubt, ma'am. Okay, thank you. So you should be very careful while substituting the values, children. There's nothing. I told you this chapter is really a fun chapter because you just have to have the formula in your fingertips. And formula also you don't have many. Just some, three or four formulae we have. That's it. And then the rest are, based on circle, quadrant, semicircle. So whatever formula is for the circle, at multiply by half for semicircle, multiply by 1 by 4 for quadrant. Okay. So you can see here. So first OP, PQ, OQ, they're all equal to 10 centimeters. So this triangle is equilateral and the central angle is 60 degrees. Then finding the area of the sector. Central angle is 60 degrees and pi the values given. See here, this value you should take. Radius is 10. Then the triangle is √3/4 into side square. Subtract, you'll get the area of the segment. You'll get the area of the segment. Then find the area of the semicircle. The semicircle which is between this chord PQ and this arc. Find the area of the semicircle which is between this chord and this arc. That's what I've written here. Area of semicircle between chord PQ and the arc PBQ. So why half pi r square? Because semicircle. Circle's area is pi r square. Semicircle is half pi r square. But radius is 5 here. Radius is 5. That's all. I usually number like this. And then area between these two arcs is equal to area of the semicircle, which is 4, minus the area of the segment, which is 3. 4 minus 3. Yeah, so I told you the other day by converse of Pythagoras theorem, this sum we saw in the last class or the class before that. Okay, so to find the area of the shaded region, it is the area of the rectangle. It's the area of the rectangle, which is 200 centimeters square, L into B, minus the area of the segment here, minus the area of the segment. See, how do we know this is a segment? Because it's between a chord and an arc. It's a segment because it's between a chord and an arc. So this is segment. You can see a chord and an arc. So this is segment. That segment will be a part of some sector. The segment is a part of the sector. Is a part of the sector. So from the area of the sector, if you take away the area of the triangle, you will get the area of the segment. Okay, so to find the area of the shaded region, it is the area of the rectangle minus the area of this segment. So we have to find the area of the segment. To find the area of the segment, you should find the area of the sector in which the segment lies. To find the area of the segment, you need to find the area of the sector in which the segment lies. So this segment is in this sector. So we have to find the area of the sector. For that, we need the central angle. So we have to find this angle. So this angle, I'll tell you, I'll repeat that method, meaning I will see that again how to find the central angle. Now we'll just assume that we found it. We'll proceed from there. So the central angle is 90 degrees. So how do you find the area of the sector? 90 by 316 to pi r square. The radius is 10√2 because this one is the radius OM, OL, OB, OA, all radius. See here, from the center to any point of the circumference is radius. From the center to any point of the circumference is the radius. In a semicircle, from here, this is radius, this is radius, this is radius, this is radius. From the center to any point of the circumference is the radius. So clearly this is the radius, 10√2, 10√2. So you know the sector angle 90 by 360 into pi, you know pi is 3.14 given here, r square, 10√2 the whole square. So you have everything to find the area of the sector. Then the area of the triangle, it's a right triangle, so half base into height. It's a right triangle, so half base into height. This is the right angle. So this is the base. This is the base, this is the height. It's a right triangle. So this is the base. The legs are the base and height. The legs are the base and height, not the hypotenuse. This is the hypotenuse. The legs are the base and height. So you can find the area of the triangle. Subtract, you'll get the area of the segment. Now from the area of the rectangle, if you take away the area of the segment, you will get the area of the shaded region. Now how to find the central angle? The question is how to find the central angle. How to find the central angle? There are two ways. One is Pythagoras theorem. Because it's 90 degrees, Pythagoras theorem worked. The converse of Pythagoras theorem. So how to work that? You must find, you know that this is the longest side because this is 10 root 2. This is also 10 root 2, but this is 20. 20 is 10 into 2. So clearly 10 into 2 is greater than 10 root 2. Excuse me. So this is 20. This is 10 root 2. This is 10 root 2. So you should do this. You should do this one. Show that they are equal. So by the converse of Pythagoras theorem, I told you this in the last class. So see, this is what you should do. This is second, children. The other way of doing it is, the other way is you should drop a perpendicular. See, from O, drop a perpendicular like this. You can call this point M or not M, P, and use trigonometry. Use trigonometry. So now this is 20. So this is also 20. So it will be 10 here and 10 here. Correct? Understand? How you know it is 10? How you know it is 10? You should prove that these two triangles are congruent. You don't have to do all that. You don't have to do all that. These two triangles are congruent. So AP will be equal to BP. AP is equal to BP. So 10 each. 20, so 10 each. Now use trigonometry. Use trigonometry. We need to find this angle. We need to find this. No, find this angle. Not we need to find this angle. We need to find this whole angle. We need to find this whole angle. But from a right triangle, from this right triangle, you can only find a part of it. So let's find this angle theta. This one is 10 root 2. This one is 10 root 2. This one is 10. So which ratio connects the opposite and hypotenuse? Which ratio connects the opposite and hypotenuse?
Sin theta.
Sin theta. Sin theta is equal to opposite 10 by hypotenuse 10 root 2. Sin theta is equal to opposite 10 by hypotenuse 10 root 2. So sin theta is equal to 1 by root 2. Cancel. 1 by root 2. So when is it 1 by root 2? Sin 45. Sin theta is equal to sin 45 degrees. 1 by root 2 sin 45. So theta is equal to 45 degrees. Theta is equal to 45 degrees. So 1/2 is 45. 1/2 is 45. So the other one is also 45. Because these two triangles are congruent. So this angle will be equal to this angle. So 45 plus 45, 90. So this, using trigonometry, you can find whatever, the central angle may be. Converse of Pythagoras theorem will work only for 90 degrees. You can use trigonometry to find any angle, any central angle. For that, you will have to drop a perpendicular like this, M. These two triangles are congruent. So this side AM is equal to BM. Okay, I said P, no, because we already have M. So AP is equal to BP, so it will be 10, 10. And then we find this angle using trigonometry. Find this angle using trigonometry. So here it is sin theta is equal to opposite by hypotenuse. So you get theta is 45 and this is also 45, so 90 degrees. That's about this one. If you have not finished the assignment, you need to go through, children. Please go through the assignment and work it. Please practice. See, I'm telling you everything you need to understand this. What you have to do is just the numerical, job. The whole idea is explained. I've told you if there are multiple radii, I've told you for which one you should take which radius. Yeah, this one I messed up, I put a different, I told you, a different figure, and this is the working. This working is correct, but the figure I attached with this is incorrect. So this is the figure. The whole thing is shaded. The whole thing is shaded. Very important question. If you understand this, you can do any sum like this. If you understand this one, you can do anything like this. Are we ready?
Yes, ma'am.
Yes, ma'am.
All right. Now see here. How do we find the area and perimeter of the shaded region is the question. How do we find the area and perimeter of the shaded region? Now it's given that this figure is made up of 4 semicircles, 4 half circles, meaning 4 semicircles. See, this is one semicircle, 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 and 2 quarter circles. See here, quarter circle, quarter circle. See, like that you get the figure. I've traced the figure. We'll do it again. 4 half circles, meaning semicircles. Semicircle, 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 semicircle. 2 quarter circles, quarter. 1 quarter circle, the other quarter circle. So this figure is made up of 4 half circles. That means 4 semicircles and 2 quarter circles. That means 2 quadrants. 4 semicircles and 2 quadrants. Now see here. OA, OA, OB, OC, OD, all are equal to 14 centimeters. Find the area and perimeter of the shaded region. Find the area and perimeter of the shaded region. Now, for perimeter, children, see here. Again, this one I have to clarify. I'll ask you a question. Please answer that. There's no place here. There's no place here also. Tell me the perimeter of this figure, children. Find the perimeter of this figure. Yeah. Work and tell me the perimeter. I don't want the explanation. I just want the answer. What is the perimeter of this figure?
Seven.
77 centimeters, is it?
Yes,
Yeah, others.
36
Ma'am, I'm
centimeter.
speaking anything right now, ma'am. I couldn't hear you.
What is the perimeter of this figure you see on the screen?
From 36 centimeter.
36. Okay, 36. I got 36 from Rajarajeshwari. Okay.
36.
Ananya also 36. Then Ram, what did you say? 77, is it? Okay, then others. Okay. So the perimeter of the shaded, sorry, the perimeter of this figure is the length of the boundary. The length of the boundary. So it's basically this length plus the length of this arc. The length of this line segment plus the length of this arc together makes the perimeter of this figure. So this one is 14. There's nothing but the diameter, it's 14. So you should have understood it's a radius 7. So this one is 14. What about the length of this arc? It's a semicircle. It's a semicircle. So what's the length of a circle? 2 pi r. Semicircle, half of 2 pi r. What's the length of this one? What's the length of this one? 2 pi r. Then what will be the length of half of it? Half of 2 pi r. Or you can write pi r also straight away. You can write pi r also straight away. Take the full complete formula. The area, the length of the circle. This full circle is 2 pi r. Semicircle meaning into half. So it's pi r. Pi r. What is pi r? Pi is 22 by 7 into r, which is 7. 22. The length of this arc is 22. Plus 14. 7 plus 7, 14. 36 centimeters is the perimeter of this figure. What's the perimeter of this figure? The center. Yeah, what's the perimeter of this figure? Yeah, please work, children. Yeah, children.
$72.
72, huh? Ram?
Yes.
Okay. How do you find the length of this arc? What's the formula to find the length of this arc? What is the formula to find the length of the circle? The circumference of the circle is 2 pi r. How much is this one? 1/4 of 2 pi r, right? So 1/4 of 2 pi r. So 1 by 4 into 2 into 22 by 7 into r, which is 14. R is 14. See, this is the radius. Completed and see, this is a quadrant. This is a quadrant. Is completed. See, this is the radius. This is the radius. When it's a semicircle, this is the diameter. Semicircle, this is the diameter. But for quadrant, this is the radius. This is the radius. Radius.
The formula is theta by 316 to 2 pi r.
Both are the same. Theta by 316 to 2 pi r also will give you the same answer. What is theta? 90 degrees by 360. So 1 by 4 you will get.
Yes, ma'am.
Both are the same. When you know the fraction, you can take the, see, 90 by 360, or because we don't know the fraction. See, when the sector angle is 60 degrees, we don't know the fraction. So we say 60 by 360, 1/6 it is. 1/6 of pi r square or 2 pi r. We know the fraction here because quadrant is 1/4 of the circle. So we take the fraction straight away. Instead of writing 90 by 360 and reducing it to 1 by 4, you can take 1 by 4 straight away when it's a quadrant. 1 by 4 of 2 pi r. Because 2 pi r is the formula to find the circumference, not pi r square. So 1 by 4 into 2 into 22 by 7 into 14. This is a radius. So 7 ones are 7 twos are 2, 2, and this one will get cancelled. So 22 you get. 22. Plus 14 plus 14. Yes or no? This is 22. This length is 22. Plus 14 plus 14. Yes or no? So 28 plus 22. 28 plus 22. Is it 50?
Yes, ma'am.
How many of you got 50? Sorry. How many of you got 50?
After you told, yes, ma'am.
Oh. See, children, there's a difference between finding the length of this arc and finding the perimeter of this figure. See, if I call this L, okay, this is a quadrant, Okay, if I call this one L, L plus radius is the perimeter of this figure. Or 2r I can write, is the perimeter of the figure. If you want to find only the length of this piece, this will be 1/4 of 2 pi r, because the length of this full thing is 2 pi r, but there's only 1/4 of 2 pi r. Or as Ananya said, you can write 90 by 360 into 2 pi r, which is also 1 by 4. Similarly, when you take a semicircle, this is L. This is the diameter. If you want to find the perimeter of this figure, it is L plus D, the length of arc plus D. That's the perimeter. But if you want to find the length of only this one, the length of only this, what's the length of the full piece? 2 pi r. How much is this one? Half of it. So half of 2 pi r, which is nothing but pi r. The full length is 2 pi r, but you want to find only half of it. So half of 2 pi r. The central angle is 180 degrees. 180 by 360, which is 1 by 2. 180 by 360, which is 1 by 2. Half of 2 pi r, which is pi r. So if you want to find the length of only this arc, it is pi r. If you want to find the perimeter, it is pi r plus d. If you want to find the length of only this one, then it is half of 2 pi r. If you want to find the perimeter, it is plus d. Is it clear, children?
Yes, ma'am.
All right, thank you. So now, children, it's actually time. Take a picture of this one. I'll explain this in the next class. I might take a class this Monday because the coming Saturday, that is today is Saturday, right? The next Saturday, I might not be able to take a class. So which I want to compensate on Monday. How many of you can take up the class on Monday, same time?
Ma'am, this Monday.
Yeah, the day after tomorrow.
Ma'am, the same.
Lower your hands. Lower your hands and raise your hands again. Yeah. How many of you can take up an extra class this Sunday?
Monday, ma'am.
Oh, Monday. Sorry, Monday. Monday, same time. Day after tomorrow, Monday, same time. Same time. 8:15 to 9:45.
Exams on Tuesday.
Oh. Okay, in that case, when are you finishing the exams?
Exam will finish on Wednesday. On Tuesday, I can run class, but Monday I come.
Tuesday we'll have our regular class. Monday is the compensation class for Saturday. Next Saturday, I'll not be able to take a class. I want to compensate that on Monday.
Yeah, ma'am. So Monday we have to prepare.
Okay, Ram, in case I make a class on Monday, please make use of the recording, okay?
Yes, ma'am.
Okay. Yeah, children, it's time. So take a screenshot of this one. This is the figure. Okay. Now, I'm double-minded. I want to finish it. I don't want to finish it because it's getting late. I don't know what to do. Okay. Now see here. The area of this figure, children. Area is very simple. Whatever is shaded, you'll have to find the area. So what is shaded? This quadrant is shaded. This full quadrant is shaded. Find its area. Then this semicircle is shaded. Find its area. Then this semicircle is shaded. Find its area. And then this quadrant is also shaded. So basically, to find the area, you'll have to find the area of two quadrants. See, there's one quadrant here and another quadrant here, another quadrant here. So find the area of these two quadrants and the area of this semicircle and the area of this semicircle. So the area of two quadrants plus the area of two semicircles will be the area of the shaded region. Now, be careful while taking the radius. See, for the quadrant, whenever it is quadrant, see in a circle how it is in a circle. This is a quadrant. This is a quadrant. So this is the radius. This is the radius. But in a circle, this one is a semicircle. For the semicircle, this is the diameter, not radius. If it's a semicircle, this one is not the radius, it's a diameter. But for the quadrant, this is the radius, this is the radius. What is attached to the quadrant is the radius. What is attached? The line segments attached to the quadrant is the radius. But the line segment attached to the semicircle is the diameter. This is the diameter. The semicircle sits on the diameter. So radius will be half of that. Quadrant has one radius here and one radius here. Okay. So now it's given it's 14 children. It's 14, okay. OA is 14. This is 14. This is 14. This is also 14. Now tell me for this quadrant, what are OA and OD? What are OA and OD for the quadrant, children? Radius or diameter? For the quadrant, OA and OD are radius or diameter? Yes. Radius. It's a radius. So radius is 14 centimeters. Now for the semicircle, for this semicircle, OD is the radius or diameter?
Radius.
For the semicircle, OD is the
Diameter.
diameter. So what will be the radius? 14 by 2, 7. So when you're finding something for the semicircle, radius is 7. When you're calculating something for the quadrant, the radius is 14. So first thing is you should be careful by substituting the values of radius. Quadrant, the radius is 14. Semicircle, the radius is 7. That's the first step. You should be careful while substituting the values for R. Step 2. Quadrant means whatever is the formula, 1 by 4 into that. See, we have only two things for a circle, okay? For a circle, we have only two things. What we have? Area, which is pi r square. Circumference, which is 2 pi r. If you're finding the area of a semicircle, 1 by 2 into 2 pi r square. If you're finding the length of arc in the semicircle, it is 1 by 2 into 2 pi r. If you're finding the length of this one, semicircle, it's half of 2 pi r. If you're finding the area of a semicircle, half of pi r square. Similarly, when you're finding for a quadrant, the area of a quadrant, If you're finding the area of a quadrant, area of a circle is pi r square. For quadrant will be 1 by 4 into pi r square area. If you're finding the length of this arc, the length of this arc, for the full circle it is 2 pi r. For the quadrant, it's 1 by 4 into 2 pi r. That can be reduced. So ones are 2, so it will be pi r by 2. It will be pi r by 2. Here this will be pi r. So that's another thing. You should be careful while taking the formula and substituting the values. For the semicircle here, the radius is 7, while for the quadrant, the radius is 14. Yeah, so area, we'll do it again in the next class. I'm just trying to make it fast so that you can understand this. So areas like that. For perimeter, perimeter is very important. Perimeter, you should just go along the boundary of the shaded region. Go along the boundary of the shaded region. See here, I start from O. I start from O. Go along the boundary of the shaded region. So see here, I go like this. I walk along OA. Then I walk along this arc AD. Then I go like this on this. I come here. Now I walk along OC. Then along this arc. This arc, and I finish it. I come back to the starting point. Whenever you're tracing the perimeter, you must come back to the starting point. See here, I started here. I went like this along OA. You should not get into the figure. You should go along the boundary. Then I went like this, like this, like this. And now I have to continue. Kamala, over 5 minutes, Kamala, on a pandran therapy. So I started here. Like this OA. I come back to the starting point, but I haven't still finished the boundary. So go continue. OC. Now you have traced, you have gone along the boundary. This length you have to find. You should find this length. See here. So this is the length of arc in a quarter circle. This is the length of the arc in a quarter circle. This is the length of the arc in a semicircle. And this is the line segment OA, 14. This is the line segment OC, 14. This is the length of the arc in a quadrant. And this is the length of the arc in a semicircle. If you're finding the length of the arc in a semicircle, full circle is 2 pi r. Semicircle is half of 2 pi r. Full circle is 2 pi r. Quadrant will be, the arc in the quadrant will be 1 by 4 into 2 pi r. If you're finding area, pi r square. For semicircle, it will be half into pi r square. For a quadrant, it will be 1 by 4 into pi r square. That's all. This is area. 1 by 4 if it is quadrant, 1 by 2 if it is a semicircle. This is circumference or the length of the arc, 2 pi r, into half for semicircle, into 1 by 4 for quarter circle, the length of the arc in a quarter circle or in a quadrant. And use the radius carefully. For the semicircle, the radius is 7, 14 by 2, 7. But for the quadrant, the radius is 14. That's all it is. You should just be careful in using the values of r, and semicircle or quadrant, you should use the fractions 1 by 2, 1 by 4. That's all. We'll get the area of the shaded region and the perimeter of the shaded region. Please correct this, children. If you've finished the assignment, please correct this one. All right. All right, children, we'll again do this in the next class or a similar one in the next class. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you.
Thank you. Good night.
Thank you.
Thank you.